Okay, class, let's start talking about arguments. Arguments are things we pass to functions, things we pass to functions. And this would apply to both types of functions that would be able to receive arguments. We can have a void function receiving arguments right in there through the intake chute. And it being a void function, it won't have anything returned. Or we can do a returning value function and provide those arguments. Now, data types are critical when we start talking about arguments. We have to keep our data types in strict order. We have to remember them. We have to keep things very neatly aligned and mapped together. So what all of that means is it's easy to get lost in the syntax unless we just try and understand it at the start. Now, arguments are always going to be in those parentheses. And it's a matter of if we're sending or if we're receiving that there are some differences. Oops. There we go. So let's first look at how do we send something to a function? How do we send it? Here's some code that is going to show what I'm talking about with respect to data types and alignment. Now, we're not talking about anything in the return space here. We're not talking about void or int there. That's just what's being returned. We're talking about what is being passed into it. So we'll be dealing with things inside the parentheses. So to call a function and to provide it some variables, we just provide those variables within the parentheses. So like if we're going to do a function called doCalcs, and we had two variables, variable A and B, we just include those, we separate them by a comma. This is not a semicolon because that will terminate the statement. We do commas to separate out items in a list. We could easily do the same function call with literals, or some combination thereof. We could even do expressions in there, anything that will evaluate eventually to an integer or double is going to work. So like here's variation times 4.2 that we'll send, and then how about var6? So it doesn't matter what we put in there. What does matter is the data type and the number of arguments. Let me say that again, the data type and the number of arguments. Why? Because these all have to line up. And let me explain that. So this is our definition here. This is our prototype. And then this is our call. And they've got a couple different types of calls listed there. Let me just erase some of this stuff. So let's look at the definition. We see the same void doCalcs that we had before, but we've just got some other things in syntax in the parentheses. So what these are actually doing is declaring temporary parameter variables. Remember that whenever you see int and something, that's creating a variable. So this is going to create a temporary variable called v1. And that means then in our code, we can use v1. We can't use v1 anywhere outside of this code, outside of this function, I should say. And that's because its scope is only the function. You can only use a variable in the function in which it's created. So that's why variables are always created in functions and passed back and forth. Constants we declare globally so that their scope or their availability is the entire program. So any of these functions that we're creating could use those same constants. So here's another integer that's created, v2, just for the purpose of the function running. And then as soon as this function's over with, these temporary variables are destroyed. Let me say that again, they are destroyed. Now, let's take a look and compare the call with that function header, okay? Let's look at this one right here. So this is do calcs, and then we send it 2 integers. Now what happens is, this calls this function here, do calcs, and the 4 gets sent in and mapped to V1, and the 6 gets sent in and mapped to V2. So when we're using our code inside the function, V1 and V2 are at least initialized to the values that were sent to them. And that's pretty cool. Now there's rules. The data types have to match and the number of arguments have to match. Let me jot those rules down and show a couple of violations. Here's a quick function, calc values. It's going to receive 2 doubles and just do some calculations and return something. Doesn't matter because we're just looking at the parameters for right now. Now, because we're dealing right now with the function definition, these are parameters. They're not arguments. Arguments are sent. Parameters are what's coded into the function. Now, when we then call this like this, calc values, that's the simple function call, and then the mapping occurs 1-to-1. So there have to be the same number. Oops, let's not do that. There have to be the same number of variables. And in our case, I think we're good. We've got 2, 1 variable and 2 variables. Same, and does that match the function definition? Yes, it does. 1 variable, 2. The data types have to match also. And is this a double? Yes, it is. Is this, and this is a double, and this. So the data types match also. All of those have got to line up and match. And then just remember the mapping. 6.2 then is mapped into V1. 4.5 is mapped into V2. Then we can use them in our function algorithm, whatever we need. Now, those aren't constants. We can easily go and redefine V1 or V2 anytime we want. Those are just temporary local variables. So that is how we send, paying particular attention to the number of arguments and the data types of the arguments, and they all must match. Now, one thing I recommend that you start when you're trying to code a function is always start with the function definition first. Try and code what you're trying to code. Worry about the call later. This is a call. And worry about the prototype later. But first start with the definition. Now, let me show you an easy way to get the function prototype syntax based on just the function definition. And so to get this prototype, we are just going to literally copy and paste all of that. We're just going to copy and paste it. So paste it and then remove the variable names. They're optional, but developers don't put them in there because they're not required. So you don't need any names at all in there in the function prototypes. The names come into play here when we create the function definition. And oh, by the way, the variable names V1 and V2, they don't have to match anything in the main function. Nothing. Those are just local variables, and we only care about them in calc values. So get rid of the 2 names of variables and then put a semicolon, and then you are good to go on this function prototype. It derives directly from the definition. And then remember, to call a function, we're just going to call calc values and put in the arguments in between the two parentheses. So let's take a look at a little bit of code that's going to highlight just what we're talking about. And I'm going to zoom in quite a bit here so you can see it. Here is our, and always start at the definition. And here's our calc values definition down here. You'll note the two parameter variables that we've made, V1 and V2. And then here we've just got some formula that we created, but we're returning it. And then, of course, we remember the rules that the data type of the return value has got to be this. Those two are two elements that must match. All right, so continuing to look down here in our function definition, and that's all this down here. It's pretty straightforward. We've got a double V1, double V2. You do have to put the word double in front of both of them. If you don't, it will generate an error here. So you have to put the data type in front of every one of the parameter variables, every single one. All right, I mentioned, let me take this out. I mentioned about how do we create a prototype. So let's just copy this entire first line. Let's get rid of the brace and put in a semicolon. Let's take out the variable names. And we are good to go. That is a successful function prototype, and this still runs and returns 64 for us based on whatever this calculation is. Let's change it up a little bit. Let's really go crazy. Let's say that we also are going to pass it an integer. And I'm just making up numbers here. So to pass it an integer also, well, let's go and change our code down here first. We'll start with the definition always. And that means we're going to add an int, and let's just call it V3 for the third variable. And then maybe V3 gets thrown into this calculation mix somehow. And now we've got a third variable. Now, when we run it, we get some compilation vomit here saying, it's weird. I expected 3 values, I only got 2. So what is going on? And the problem is we didn't yet update the prototype. So let's do that. All we do is add in the third data type, and that's an integer. And then when we run it now, you'll see that we get some results. So that's a real quick way to add things. Now, the rule is that you can add in any type of variable. Let's do a string now. And I'm going to even throw in a string. How about that? And I'm going to break this up onto separate lines. I'll call it string v4. And we'll send it that string. So now we get the nice message as part of our function execution, welcome Joe, or whatever we sent to it. And then we do the operations. We were sent in v1, v2, v3, a double int. And does that match these? Yes, it does, double int. So we've got to make sure that double int matches double int matches double int. A good part of manipulating your functions is just guaranteeing that alignment in both data type and the number of arguments. Now, instead of sending literals, we could easily send some variables. Let's do that. All right. So there I've initialized and declared a couple of variables, a double int string. And because that matches this right here, double int string. And then now for our calculate values, we just need to put those variables in, value 1, value 2, int 1, and name. And then when we run this, you'll see that we get the same output. And it's identical really just because we've sent the exact same values, just we sent them in the form of a variable. Now note a couple of things here, and I'm going to just highlight this on the screen because it's so easy. Note that value 1 here has to map to this. Those two map together. But notice that value 1 as a name and V1 don't match. They're not the same name. And they don't have to match. This is where something doesn't have to match. And it sort of makes sense. We wouldn't want to require that they match because that would then violate the purpose of code reuse. In int main, we might send val1, val2. Maybe next time we're sending value 9 and 10. And we don't want to have to keep rewriting the function just to keep the variable names the same. I'll show you an example of what I'm talking about here. I'll do a value 3 now. And let's do an int 2. And we'll give that the universal answer for everything. Now, this time when we call calc values, let's just go crazy. And let's, instead of sending 1 and 2, this time we'll send 2 and 3, and let's send int 2. So we're sending a completely different set of arguments to the same function, and it'll then go and do its magic. And there are the two outputs from that run. So that underscores, hopefully even better, that these values do not need to match those parameter names. They can be anything that you want. And then as a matter of review, the two things that do matter are the number of arguments. Those have got to stay the same. 1, 2, 3, 4, 1, 2, 3, 4, and down here 1, 2, 3, 4. And of course, then the data types for each of those 4 must be the same. Let me show some code now that's going to explain how a function does not alter the original values. So when we send data to a function, we're not sending the original variable. We're actually sending a copy of it. And it's that copy that gets sent. That means the original is left intact. And let me show some code to demonstrate that. Here, this is the same code as we did before. I've just commented out all of this stuff. So when you go and fork this demo code, you'll want to remove some of these comments. And to do that wholesale, just highlight the lines that you want uncommented and press Control /, and you can then toggle those comments on and off. Okay, so here I've got inventory is 100. I'm going to output it, but then I'm going to send it to a function that I created called change value. So let's take a look at that. Here's change value down here, right here. And it receives an argument. It's going to receive a value for A, and then we're going to attempt to change it to 15. Whatever A is, we want it to be 15. But when we run this, we see that after we run, or after we call that function change value, we see that in line 19, inventory is the same. It is unchanged. And that is because the function only manipulates a copy of it and not the original. And that's by design. A lot of programming languages are like that. It's beyond the scope of this course, but in COMSC-165, you'll learn about reference variables, which will change this behavior. You can send a variable by reference, rather than by value, and it'll update itself in the main program. And I'll show you how to do that. Here's the change value prototype. We're just going to add the ampersand character in there, and we're going to add the ampersand character in here, and it now changes it, and it's permanently 15. Like we're saying here, it was 100, now it's 15. So that's how to permanently change it. It's just to use reference variables. Read that, read that part of the book, and it's simple. Just put an ampersand in front of that variable. I'm going to step through some of the demo REPLs. This is program 6.6 from the book, and it is just simply sending an argument to a function. So here's the function called display value. We're going to send this 5 to this function, and it gets sort of reassigned. The value gets assigned to the variable number, and then that number is counted inside that function. And we've got good alignment. Here is int. So we've got int aligning with int, aligning with int. So that means that we are good on that. Program 6.7 does the same thing. It just calls the display value function 4 times with different integer literals each time. Program 6.8 in the book will use 3 arguments. 3 integers are sent to the function, and these arguments are actually entered by the user here, and they're then sent to the functions. This goes to num1, to num2, and to num3. They're mapped in order, and it looks like we've got good alignment with respect to 3 integers here, 3 integers here, and 3 integers here. Program 6.9 shows how a number is not changed inside of a function. So this kind of is just what I just demoed here. Let's run this. We'll see that we get a 12, a 0, and a 12. So where did those come from? The first one is right here. That's our first count, that number is 12. Something's going to happen here. Then here's the third count saying number is, and it's still 12. So let's remember that. However, when we sent this number down to the function changed it right here, saying my value is 0, and even counts it. But remember that since a copy was sent to the function, not the original, then that change is not going to be persistent. It's not going to be evident or visible in main. And we're seeing exactly that here. You know, we're seeing that the number is 12, and that was unchanged. It was supposed to be a 0 here. So remember that behavior. And then the quick trick on changing the behavior is to just put an ampersand behind the data type of the variable that you want this two-way communication to happen. And look at the change now. Here we changed it in the function and outputted it. But then look, the change is now persistent. The change is evident in main. So we know that that variable actually changed. How does that do that? Well, if we're going to send something like this, it's called sending by reference. Read that part in the book. It's outside the scope of this class, but it's good to know. And when we send something by reference, we don't send a copy. Nope. When we send it, we send the original to the function, and the function's going to alter it. And when we get it back, it's the original. So remember that behavior. I'll take these out for now. This is program 6.12 from the book, and it deals with return values. So let's check it out. Down here is our function definition, and it looks like we have got a return value. We've got an int there. So there had better be a return statement and then some expression or some variable that's actually being returned. Now that we see this definition here, this function definition, let's just do a quick check. It's an int for return, and the two parameters are also int. So let's just double check that. Let's go up here to the function prototype, and is it int return and int parameters? It sure is. Int return, int parameters. Let's look at the call. Is it int return and int parameters? Okay, well, total is going to hold the return value from the function, and total is an integer. So those will match up. And then we are sending it two integers, value 1 and value 2. So everything does line up with respect to the number of arguments and the data types of those arguments. So we run this and we get a simple response back of just what the total is, and then we get to output it. Now, when I keep saying, don't forget to catch the return value, you have three options: store it in a variable, count it, or use it in an expression. And in this example, we are storing it in a variable. Try and find where we're storing it in a variable. And if you found it right here, you guessed right. Line 17 is where we are storing it. The processor is going to reduce this whole side here, have it reduced down to hopefully one value, and then that gets assigned to here. And now that it's held in the variable total, we can hold on to that forever as long as we need to. Okay, now we're on program 613 from the book. And let's look at the functions first. There's a couple of them: get, radius, and square. And those seem pretty simple. The neat part about this function is that we are actually getting the user's input from inside the function. And that's kind of cool. It modularizes our code. It puts the input operations in their own modular code, in their own function. So it simplifies and really neatens our main program's code. So do that. You can have input, you can have output, you can have file operations, whatever you need. You can do it all inside of a function. So here we get that, and it returns the radius of the circle. And then here's a square, and it just returns the number squared. Pretty easy there. So we have these two functions, get, radius, and square. We saw that the function definitions, they're off the screen now, but get radius is going to return a double, and it has no arguments. So let's look at this. Yep, it is returning a double, and it has no arguments in there. And then you'll see that the other one lines up as well. Now, check out this code and tell me, where did we catch the return values? We can either count them, assign them to a variable, or use it in an expression. What did we do here? Okay, well, hopefully you answered. Aha, right here in line 23, that's where we assign the return value to a variable, in this case, radius. Get radius is going to literally replace all of this text with something like this. And the processor then just looks at that value and goes, okay, I'm assigning it, and we're done. So that's what literally happens. The text that comprises the function call actually gets overwritten with the return value. Now, what I mean by a return value dropping out, not being caught, and just being lost is this. What if we did this, just get radius? Well, we could do that. When we run it, we'll first get the first time we run it, 12, and then we're running get radius again, and this time we enter 13, and it gives us the area from the previous one. But you'll see here that, just this function call alone means that it's going to be replaced by whatever the function returns. So let's say it's this. Now, how would the compiler process a C++ statement like that? 1234.4. It can't. It just does nothing with that. It'll still compile it. This is giving us a red squiggly line under it saying, this is kind of weird code. It'll still compile, but that's not what we want. And it does that because we forgot to assign the return value to a variable. Or we could just simply count it. And then where was the other catch? Well, I hope you saw that it was right here. So there's the function call, square radius. That's the function call to this square function that we saw down below. And that returns a value. And that value gets literally substituted. So this math formula becomes area equals pi times some value. So this is an example of the third case of using a return value in an expression. You can use it in a math expression. You can use it in some more complicated algebraic expression. Any of those is good. Okay, finally, we've got program 614, which is a fairly well-integrated program. Let's take a look at it. We see that there are 3 function prototypes here. So let's take a look at those function definitions and get an idea of what they do. Show intro, get cups, and cups 2 ounces. So let's take a look and see what's going on with those. So here are the functions, and let's first look at show intro. That's this one right here. It's a void function, argumentless function. So this is going to just perform some task. And sure enough, it does. It performs the program banner. It outputs the program banner, I should say, and gives an introduction to the program and some other information. So show intro is just going to boom, blast out that count statement. Now, check out get cups, though. This is going to be an awesome function because it's going to do a couple of things. One is it's going to get input. And if we can, sort of outsource our input to a function, then that really is going to make our code neat. And whatever gets input, let's then just return that. Now, a glorious thing to do too, now that we know while loops, is to do our input validation here within that function. Now, I'm going to actually add that in here because Professor Gaddis did not put input validation right here. So why don't we say that for input validation purposes, the number of cups has got to be 0 or greater. So let's pop in a quick input validation loop for that. There we go. A quick little input validation loop. And you can see then, I'm going to run this now, and we get the banner, enter number of cups. I'm going to enter a bunch of negative values, and finally I'll have a positive value. So that's what double get cups is going to do for us. And remember, it returns num cups. So we've got to do something with that. We've got to catch that. The other one is just a simple conversion program, cups 2 ounces. We give it cups and it's going to return ounces. So that's going to be a very easy program to both visualize and to put into practice. So now let's look at the actual code in main. So we have a double for cups and ounces. We've got some housekeeping in line 13. We've got show the banner function in line 14. But then look at 15. 15 is beautiful. Cups equals get cups. So that means get cups is going to get the user input and validate it and return it. And that variable cups right there is going to catch it. Then we get a simple conversion. We want to convert whatever those cups were to ounces. So we'll just set that return value into a variable. We'll assign it. And then that gives us two variables to manipulate in line 17 and 18. And we can decide to just output them. So this is a good program showing void and value returning functions, and one function that has a parameter. Okay, we're going to mark the page here. Hopefully this is enough to get started on functions. I know that in this incredibly accelerated course that, learning functions in one module is extremely hard. But this is what we signed up for, so we've got to learn functions in one module. If you took the regular 16-week course, we'd spend about a full week and a half with these functions. But this is what we got. Okay, so good luck, everybody. Please pop your questions up there into the discussion board, and we'll see y'all online. Okay.